let's draw the molecule given the name on the screen. The first thing we note is that this is an octene, so it's going to have 8 carbons, and the alkene is going to be at the 3 carbon. So we'll start this problem by just drawing an 8-carbon chain. 1, 2, 3, 4, 5, 6, 7, 8. Since the alkene is between carbons 3 or starts at carbon 3, we can draw that here. So this right now we've got oct3ene, and we can number these carbons 1, 2, 3, 4, 5, 6, 7, and 8. That is oct3ene. At this point, we have to put an ethyl group at carbon 4, so we can draw that here as our ethyl group at carbon 4, and we need a methyl group at carbon 5. Now, this problem doesn't specify the stereochemistry of the methyl group, so we won't worry about making it wedged or dashed because we don't know whether it's RS. We'll just draw it this way. This would be the molecule 4-ethyl 5-methyl-oct3ene. The only thing we'd want to check here, because we drew our octene just using the normal up, down, up, down, up, down that we tend to do, we should double check at this point to make sure that our alkene is still E, given that we've added substituents. And so to confirm the E, let's draw in the hydrogen here and recognize that carbon versus hydrogen, that's going to be our number 1 priority, with this hydrogen being the 2 priority. When we look at carbon 5 versus carbon 4 is a CH2 with a carbon attached. Carbon 5 is a CH with 2 carbons attached. It's going to be the 1 priority. This one would be the 2 priority. Imagine our line cutting through. The 1 and the 1 are on opposite sides of that line. So this is, in fact, the E alkene. This molecule represents the structure whose name is on screen.